Okay, so this video solution is to show you how to find the equation of a sinusoid when you only have a partial sinusoid to work with. You don't have the entire graph, so you can't get all of the information that you would like immediately off of the graph. So this problem here, in problem 17 and 18, a quarter cycle of the sinusoid is shown. It's key that it tells you that it's a quarter cycle because that allows you to figure some information out about the graph. And we're supposed to find a particular equation for the sinusoid. So if I look at this, right, a quarter cycle, that means that it's going from peak to middle or middle to bottom. So from the sinusoidal axis to either the maximum or the minimum of the graph. And if we take a look at this, we can tell by the curvature of this graph, right, that here it's flat, right? So this has got to be the bottom. And therefore, this is the middle. So if I think about it, I know that it's going to continue going up from here. And if I think about it some more, I can easily figure out that it's going to go up. How much more? Well, the same amount that it went from the bottom to the top, because I know that it's symmetric around the sinusoidal axis, right? So this is the sinusoidal axis here. And since it goes 9 units from the bottom to the middle, it's going to go to 9 more units to the top. So 9 plus 4 is 13, right? So I'm going to go ahead and I'm going to draw 13 on here, and it's going to go up to the top, right? And let's think about this. How many more degrees is it going to take before I get to that peak at 13? Well, a quarter period was 70 to 200, so a quarter period, again, would be another 130 degrees. So here, this peak is going to happen at 330 degrees. And then again, it's going to come back down, right? And that's another 130 degrees. So this is going to be 460. And then it's going to go down to the bottom. And then this is going to be another 130 degrees, which is going to be at 590. Okay, so now I have a whole cycle. So really, at this point, all I have to do is figure out the equation for this sinusoid, for which I have an entire cycle. It should be easy to figure out what's going on. So let's read off the 4 pieces of information I need to know. So the sinusoidal axis. The sinusoidal axis is at 4. The amplitude is how far I go from the sinusoidal axis to the peak, which is going to be 9. The phase, well, we kind of have to do all of the x ones at the same time, right? So let's go ahead and figure out the period. The period here, so a full cycle would go from this point at 70 to this point at 590, right? So the total distance from 70 to 590 is 520 degrees. Now, 520 degrees is the period, but that's not necessarily, well, that's not what's going to go into my equation. So to figure out B, I know B is 360 over the period. So in this case, it's 520. Now this is actually not something that I can do easily in my head. 360 divided by 520. Well, they both divide by 4, right? So this is going to be 90 over 52 divided by 4 is 130. I don't think that reduces anymore. Well, it's 9 over 13. Super. Okay, so B is 9/13. Um, and then the phase displacement depends on what type of graph I want to write this as. I can write it as a sine graph or as a cosine graph. Let's go ahead and do a cosine, and we'll then know that the point that I'm looking for is when the graph is at its peak here. So it is, the phase displacement is 330 degrees for cosine. And then when I take this information and I put it all together, I get y is equal to 4 plus 9 cosine 9/13 theta minus 330. Awesome. That's all there is.